So yesterday we built KNN, K nearest neighbor, and also before that we built logistic regression. So we've been completed three models so far. And just one moment. So let's right click and edit with Notepad Plus. Okay, so here we go. Today's date is 16th. Okay, so we started classifications, guys, and in classifications, we completed logistic and SVM and KNN. We are done. Yes or not? So three algorithms we come first. You hear me? Good. Okay. Yeah. Okay. So Logit we gave 92, we get 92, and SVM we got 95, and KNN also we got 95. And today we'll understand naive-Bayes algorithms. But before naive-Bayes algorithms, I wanted to give you two projects. And in terms of SVM and KNN, just have a look at it. Projects. Yesterday, did I share KNN code, guys, to you? Did I share KNN code? Just one moment. 12th, 11th, and 12th. Yes. Yes, sir. It says VM. No, KNN also I shared, isn't it? 11th and 12th. If you open 12th folder, folder, there is a folder called projects. Once you expand to this, you do have few things like KNN and SVM. And the breast cancer, okay? We need to predict the breast cancer. KNN also has been shared. Project folder, I shared two more projects, which is breast cancer, and I will open this one. I'll show you KNN and SVM. Just go ahead and we do this. Okay, this is called KNN breast cancer classifications, and as let's predict. This is not resume projects. These projects should help you to boost up your, working skills towards insights finding and model predictions, all those things. So here, Pulsar data dot test. Just one moment. Let's open both of them. Okay. Okay. So this is what data set we have, and 1 second. So we have. I'll tell you all the Pulsar means it's don't bike. Don't misunderstand that, guys. Okay. Show you and sets contain these variables skewness and excess curtoise and many things. I'll give you a little bit heads on, a little bit light on this data set. So what exactly this data set is all about. So let's go ahead and KNN classifier, and this is SVM. In KNN classifications, we already discussed what is meant by nearest neighbor, how K nearest neighbor intuitions, how do we impute K nearest neighbor, all those things we completed, isn't it? So here, what are the distances, matrices, how to delete the neighbor of neighbors, everything's been done. And the first thing, let's start NumPy, Pandas, Matplotlib, and import data set. Once we import data sets, we get data like that, and then we can see the top 5 rows. So we can see that there are 699 instances and 11 attributes in the data sets. So how many rows we have? 699 and 11 columns in the data set description. It is given that there are 10 attributes and one class which is target variable. Yes, guys, whether diabetic or non-diabetic, I can say that. So just go ahead SVM and in the KNN, yeah. So breast cancer. So does the patient has breast cancers or not breast cancers? all those things we have. So in this data set, what happened, how to rename the columns, and it's very simple. The way we build the model, we can follow the same things. And I'm already sharing the two of them, how to convert to the imputer data frames, how to make a EDA exploratory data analysis, missing values, and then we try to find out the optimal features before we go ahead to build KNN model, guys, right? I already shared the two data to you. I want you to please work on two of them and let's understand, guys. All right. So let me close this and let me close this. Will you do this? You know how to plot the heat map and all those things is given up here. This is KNN classifier and this is SVM. Vector means Python. So here we build what is support vector machines. We discussed this is hyperplane, marginal distance, two separately linearly separable, non-linear separable, all things we discuss, and also RBF kernel. When I say RBF, this is the equation it implements. When we talk about sigmoid kernel, this is what the formula has been implemented. When we talk about SVM scikit-learn, everything is take care of scikit-learn, guys, as I keep on says it. So here, attribute. Each candidate is described by eight continuous variables and single class variable. The first four are simple statistics obtained from the integrated pulse file. You know what is meant by pulse, guys? Entire body runs with the nerves and pulse, isn't it? The four variables are similarly obtaining from the of the integrated profile. These are called, the healthcare terms and excess curtois of the integrated profile, skewness of integrated profile, mean of the curve, all those things we have. So very simple. Normally we have some data and we try to build a model. We try to VM model on the given data set. So that's why yesterday I already shared this two folder. I want you to open the two folder and let's a little bit explore the data. If you have any question, you can ping to me. There's no need to worry. So yesterday I shared this KNN, and I hope everybody's done hyperparameter tuning for those two tasks. Go ahead, check this. Okay, if you're not done, please work whenever you're free, guys. And today I will exploring very important concepts called KNN. What is KNN? I'm sorry, naive Bayes algorithms, guys. So okay, so projects, three things as given. Please work on this. Once again, I'm keep on saying the projects part. Please complete. All right, now let's May month and 16. So nearby algorithms I explain 2 days, today and tomorrow. So the first thing in machine learning journey, logistic, logit, and NB, Neighbors algorithms. These two algorithms are probability algorithms. What we call, guys, probability algorithm. So these two algorithms mostly probable algorithm. Understand this, guys. I mean to say logistic and naive mostly these two are probability algorithm. Okay. So to understand naive algorithms, first we need to understand what is meant by conditional probability. What is meant by conditional probability? One understand conditional probability, then we need to understand Bayes theorem. What exactly, guys? Bayes theorem. Once we understand theorem, then we understand naive Bayes algorithm. Understand, guys? And once we complete this, discuss. I mean, what are the type of naive Bayes we have? Understand? In real world, where we implement this algo, in real world, let's say the ticket price confirmation. So largely they'll use the ticket price confirmations, whatever tickets, maybe bus, train, or flight. In backend, been use this model to predict, I mean, what could be the probability of your tickets, means whether 80% probability your ticket is confirmed at, or 20% probability the tickets are not confirmed. So ticket price confirmation is one of the one of these things in naive algorithms, guys. So before I start naive, we'll explain every topic math behind all the algos, and then we cover it up. So the first thing, the let's discuss conditional probability. Conditional probability. What exactly mean by conditional probability? So listen to this, guys, and we'll disclose more in this one. Have a look at it. So the first thing, see the graph, if you see the graph, I'm sorry, if you see the equation, the conditional probability equation, how do we read that? To find the probability of A, how do I read that? This part as, I can say, to find the probability of A, event B has already occurred. So we have two events. When I talk about probability, we have two events, guys, event A and event B. So the equation of probability of A and B is equals to probability of A intersection B divided by probability of B. This is what your conditional probability of equations. So how do we read this, guys? So to probability of A equals to probability of A intersection B divided by probability of B. So what exactly mean by that? So guys, this is math equations, and I have to tell you one more time so that you get to know Bayes algorithms. So in this case, listen, let's plot a Venn diagram. This is called Venn diagram. I hope you heard about this. What's Venn diagram? Whenever I'm talking about all the events will come into the pictures. So there are two events, A and B. So even A and even B. So assume there are 40 students. The 40 students likes to eat apple. Just one and right click. Okay. So I can say this. Let's open the graph. In this graph, assume 40 student likes to eat chocolate and 30 students they like to eat fruits. Understand, guys? 40 students like to eat chocolates and 30 students likes to eat fruits, and there are 20 students, means A intersection, they wanted to eat chocolate and fruit both. Do you understand, guys? In this example we have two events, A and B, and A intersection B. So what I'm saying, 40 students they likes to eat chocolates and 30 students they likes to eat fruits, and there are 20 students who wants to like to eat both chocolate and fruits. I can say, what is the probability of B? The probability is 100. The probability of B is 30 by 100. Can I say this, guys? Which is 0.3. And the probability of A intersect B equal to 20 by 100, which is 0.2. And to find the probability of A, even B has already occurred, equal to 0.2 divided by 0.3, and the answer is 67% in this case. Did you understand, team, what I'm trying to say? Online team, are you clear or not? Online here and here, hear me as well. So very simple. What I'm saying, we the first thing is, before I go ahead by to understand conditional probability. In the conditional probability, what exactly the condition is given, we need to find the probability if the condition is given, guys. So the probability formula is A intersect B, A by B equal to A intersect B divided by probability of B. Just give me one second now. Okay, let's. So as just now we discussed what's meant by conditional probability. So here we can question. So neighbor algorithm entire machine learning algos are math equations, and I'm trying to teach you the equation every model. In logistic, we understand probability like sigma 1 plus e to the power minus e. This is what we covered. In SVM, we covered minimize w by 2 ci into epsilon ci. Okay, that's SVM. In KNN, we impute Euclidean distance or Manhattan distance. Are you understand or not what I'm speaking, guys? I mean to say, every machine learning algorithm is a math, and I am trying to fit the math equations to the data set. Okay, with the help of S entire inbuilt functions, inbuilt math, I can fit into the data, and based on that, I train the past the future data. My model is predicted. And once the model is predicted, I pass future data to the existing model, which of is 89 or maybe 92 and SVM 95 and KNN 95. And based on past, we predict the future. And the future predictions versus real time, if match, then go for deployment. And that's the way most of the companies they can try to do the business forecasting means this quarter the company is going to profit of like 50%. Next year the company is going to profit of 30 years. So if you work in any the organization, guys, the more focus on forecasting. When you're roaming around the managers keep talk about your your every time I say to the students, the one who working professionals, guys, it's not learn the course. I want you to implement whatever I'm saying every day. Please implement in your projects, in your work. Try to sir, how to know the condition of data. So what is meant by condition of data? Do you know we talk about skewness? Yes, Rahul? Positive skew, negative skew, zero skew. If you work the projects, then you must know the conditions of the data. If data behaves negative skew, you need to smoothen the data. What's meant by smoothening the data? You need to find out the right attributes. You need to spend more time. So what I'm saying, whenever you work any projects, you need to work with a team. You need to work the projects with a team. Even though you choose a right dependent variable, you must have discussions with. your manager, your client, isn't it? And everybody stick to one plan, then the product is developed. Can we say this or not? There's a two things, guys. The one is existing one student from 6 p.m. Okay, his name is Rajan. So he built a Python code, I mean, long, lengthy of code to build a decision tree. I explained decision tree algorithms he implemented in his project, and after complete the code, such a fantastic message he dropped me. I impressed and I said, "Great, buddy," because all the learning. Why you learn, guys? You need to implement this learning in your real time in your organizations. If you're not doing, then you must be doing some mistakes. If you're doing, you are in a right path and right directions, and that would you achieve your target, guys, and achieve your high salary. Trust me, guys. So doing means adding new concepts, new skills to your existing data. If you don't know, just go and help with the Chat GPT. You take a subscriptions of your phone also. In Chat GPT, you can enrollment to Chat GPT and you can learn many things, guys. I hope understand. Very simple. I can ask these questions as naive bias. Okay, naive bias algorithm. So when I just open, okay. So I hope understand. So this is not, I mean, due to number of high and now this is also charging, guys. Now it started charging. I think I take a Chat GPT sessions, and if you open a Chat GPT in mobile, it will cost you minimum like 32 bucks something. I doesn't remember, but you can find out. So very simple, guys. So today we start NAPIs. What is the project flow? The project flow, any industries, maybe in one of the company like Accenture, Cognizant, and Virtuous, and all of the companies, whatever you're working, even though very simple, the data extractions. This is the first one. This is the first step. Once you, it could be anything based on industries to industry difference, and no training institutes gives how the data extractions. Let's maybe Wipro company extract the data using DB. Other company extract the data from weblog files. Other company extract the data from the API. Company extract the data from like streaming. Other company extract the data from cloud, and other company extract the data from the data client shared the data, and other company extract the data from satellite. For example, about us data extractions done, guys, based on the satellite, isn't it? And all data are unstructured data. So this is the first process. The first process is data extractions. Once we extractions data, the second process is data. So data cleaning happens on both unstructured data and structured data. If the data is unstructured data, what you do, you need to remove the noise marks or noise marks, and you need to remove the noises of the pictures, images, sound, and all those things. And every project has a goal associated with your projects, a goal associated with the projects. Right, guys? I mean, what are you trying to do in structured data? Once you get to know, then you need to must implement statistical techniques. What is statistical? You need to implement descriptive stats versus inferential stats. Both you need to implement. Once you implement, then you implement like packages, NumPy, Pandas, Matplotlib. Then we import the data, Python, or it could be. You can work in any platform based on this. Once we import the data set to the Python, split mandatory, scaling is mandatory, and then if it's regressions, please implement all regressions models like we discussed 5 models. And if it's a classifications, then you can implement to 5 classifications model. Once we build the model, pass to let's compare with y test versus y pred. I don't know how many of them understand what I'm saying right now, but if you listen very carefully, and I hope everybody's clear. And once you do this, then what we do? Can then we can pass the future data to the existing model which we build. Existing model which we build. One the exist what happens, the model is generate some of the future predictions, and then we compare versus live data. And then do some three cases. All test cases are passed. We deploy the model, and once we deploy, then we go for like maintenance. So this is one part of the projects. This is one part of the projects. What is the other part of the projects? The other part of the projects might be you need to deploy into Android. So when you deploy into Android, you must require an Android developer, isn't it? And you need to create a front end, you must require a front end developer, isn't it? So if you want to in websites, you want to add another, I mean, you wanted to push, you want to come in of the project. So that's why to complete one projects, there are multiple technology involved in it. Also Java, also C, also C++, also SQL, also data science, and also predictions, also deployment and cloud. That's called product, guys. Did you understand what is meant by product? Amazon is one product, Flipkart is one product, Me is one product, Swiggy is one product. Do you understand? So it's not that a lot of freshers they have misunderstand. I will complete data science, I get a job. So that is when you 4 years colleges, do you think entire 4 years you study only data science? No, right? So again, I push you to 8:30 a.m. batch. If you BTech, in your resume, please add whatever the BTech projects you done. Please add. Along with that, I will share projects. Please work on it. Understand, guys? This is for fresher suggestions. For experiences, the work keep it. Plus, add the data science technique and take one data from your organizations. Anyhow, out of 55, maybe you guys worked as leaders, I mean, managers, data analysts, definitely take one data set, start understanding, start building ML model, and you know the business, build them, implement same that as your resume projects. Trust me, you will get a call. Trust me, I hope you understand, guys, what I'm trying to say. So today we'll go ahead and understand naive Bayes algorithms. Naive Bayes algorithms, as I said, because most of them join now, the first thing is conditional probability. And the formula of conditional probability is to when the probability of A event B has already occurred equals to A intersections B divided by probability of B. Can I say this or not, guys? So just now I show a Venn diagram. So assume in a school there are 40 students likes to eat apple and 30 students likes to eat banana and 20 students like to eat apple and banana both. So that's why A intersect B is 20. And let's assume, so how to find out the probability of B equal to 30, which is zero point 0.3. Probability of A intersect B 20 by 100, which is zero point 0.2. Now just now the equation of A by B equal to A intersect B divided by probability of B. That means zero point 0.2 divided by zero point 0.3. The answer is 0.67. I hope conditional probability is clear. Now, when you go back to ChatGPT and when you go back to Google here, and just one second, you can find out conditional, just one moment, conditional probability. We have this one, guys. Did you see this? A by B equal to A intersect B divided by 2B. Are you getting my guys? The same formula are we discussed right now or not? Are we discussed right now the same formula? 8:30 M batch. Are you me? Are you getting my point I'm trying to say? Yes, guys? Okay, that's great. Now, next step, conditional probability, clear. Second one is naive Bayes, Bayesian theorem. So Bayesian theorem, also called Bayesian theorem. What exactly Bayesian theorem? and how exactly this is very, very important to find out the probability. So naive Bayes algorithm is probability algorithm. When you attend the interview, they will ask you naive, what is mean by naive in naive Bayes algorithm. This is what interview questions, guys. The interview question is what mean by naive in naive Bayes algorithm. Then the answer is we considered two independent event. We considered two independent event, and those events are probability A and probability of B is called naive in naive Bayes algorithm. Team, understand or not? This is what you need to answer, and what to called naive in naive Bayes. We considered two independent events to compute the naive Bayes, so that's called naive in naive Bayes. So in this graph, we say two event or not. A is one independent event, B is one independent event. So these two events we called as naive in naive Bayes algo. Am I clear, team? Okay. The next one, Bayes theorem. Most of them called most of them called Bayesian theorem. What exactly this theorem? See guys, I can complete the practical, it doesn't important, but wherever you learned, they won't explain. So most of my students they placed. I mean, I'll give you in-depth story behind each and every algos because I researched a lot and explained to you so everybody can digest the concept. So Bayesian theorem, this is just another equation. This is just another math formula. And I will implement the math formula. I'll show you right now. Have a look at this. Just minimize. Are we clear conditional probability or not, guys? Now the next one, Bayes theorem or Bayesian theorem. The equation of the Bayesian theorem is like this. This is what equation. When I show this formula now, trust me, you not understand. After 10 minutes, when I explain, then you understand how. Look at this. I was about just talking about what, guys? What is the conditional probability? To find the probability of A by B is equal to what is the equation? A intersect B divided by probability of B. Can I write this? Just now I was talk about it, isn't it? This is called conditional probability equation. What if I probability of B by A? The equation is probability of B by probability of A. Can I write this yes or no? Can you answer? Can I this thing equations or not? I hope understand, isn't it? Yes, I can write this because A by B equal to A intersect B by probability of B, and B by A equal to it. Now here in this equation, this part is called posterior probability. What we call, guys, this part? Posterior probability. This part called likelihood. This part we call as likelihood. And this part we mention as prior probability. This part we mention as prior probability. And this part we mention as marginal. So what are the topics we have in Bayesian theorem? Posterior probability, prior probability, marginal, like 1, 2, 3, 4. So how the equation born, listen to me and immediately solution. Look at this. Listen to me. Any questions, you can raise your hands and let's have a discuss because this is one of the fantastic algorithms most of the real times we've been implemented. So that's why I take a stress on each and every points. So just now we covered conditional probability. Can I, is this conditional probability or not? A by B, A intersect B divided by probability P. Just now I told you. What is the denominator? So this is divided by 1. Can I say this? The denominator is 1. Now above this, B by A divided by 1. Can this form or no? A by B, A intersect B divided by probability of B. Good. And B by A, denominator is 1, is equals to probability of B by B intersect A divided by probability of A. Possible? Can we write this? We can write. Let's do a cross multiplications. Do this, do this, do this, and do this. What is this we call? Cross multiplications. I hope in 10th class everybody done the cross multiplication. We understand machine learning. Yes, damn true. We are understand math behind machine learning. Please us, and then you got to know what exactly we have. So here, if you see this, let's I A by B probability of B. Can I write that? A by B into probability of B. A B into 1 is A intersect B. Can I say this, guys, or not? And B intersect A into 1. Also, see, 3 into 2 versus 2 into 3 equal or not? 6. I mean to say, in the Venn diagram, there are 20 students like to eat apple and banana, isn't it? 20 student means A intersect B, like are not. Did you understand what I'm trying to say? Both are 20, intersect B equal to B intersect A, both are same. So that's why what I do, this is one, this is one. Let's do a cross multiply. And I found A by B into probability of B. This is one part. And A intersect B to intersect, write the B intersect A here. Or else you can also been right here, but that's not required. B to probability. Do you understand, guys, up to this now? Up to this, everybody's, yes, both are common. Yes, guys, this line, are we clear? 8:30 a.m. batch. Yes, guys, are we clear or not? Fantastic. Now, once we clear, let's do this. A by B, A by B is equal to, you can ignore it, B by A divided by probability of B. Can we get this formula now? This is a, do you see how we come to formula? Now the formula is easy. Now the formula, are you getting my point? How we create a Bayesian theorem equation? The Bayesian theorem equation is very simple. That's what I'm saying. To understand Naive algorithm, the first thing you must need to understand conditional probability first, and then you must need to understand Bayesian theorem second, and then we go ahead to the Naive algorithms, guys. Very simple. Just now I talk about A by B is what we covered, and I can say Bayes theorem. Just go back. Are we get the formula now? Now you can ask the one who learned data scientist. You can ask, can you please show the formula of Bayesian theorem? They don't able to explain, guys. Okay, so spending money is not important. Understand the content and applications in real time and applications in your organization is important. So every formula I will tell you the in, so here events, how many events, A and B, two events. Now Yamini, take this formula and you mentioned this A and B, and probability of A given B is true, B by A, probability of B given A is the independent probability. So the independent probability called naive in naive Bayes. This part we call naive in naive Bayes. Did you understand, team, what I'm saying? Clear? Okay. Now, where we understand the math formula, now can you explain where you implement? Okay, did you see when you work in a 10th class, when you work, study a lot of play card? Do you know, have you know play card? Play card. Assume how many, I'll keep a deck in front of you. What is meant by deck? Play card deck. How many play card we have in one deck, guys? Anybody? How many play cards we have in the deck? 56, 52, 56 or 52, guys? Wow. When I ask play card, everyone responds quick, isn't it? When I ask formula, no one responds. Means, I hope you understand. Just kidding, guys. No, I think 52. All right, guys. Yeah, I mean, really, you don't know? Okay, today you go and buy one play card deck and count and tell me tomorrow. Isn't it? Just very simple. In play card, we have 52 play cards. How many cards, guys? 52 play cards. And in every deck, we have some face card. What are the face? Somebody tell me. Oh, is it? That's fine. What are the face card? King, Queen, and J. Oh, no, Joker. No, Joker, you cannot consider it as a face. Joker, you have entire body, isn't it? Yeah. So they have Jack. I mean, A is not a face card. Are you getting my point? So what I'm saying, in play card we have 52 play cards, but in face card we have King, Queen, and J. Okay, K, Q, J. So how many face card we have, guys? How many face cards so far? King has four card. No, King has four card, isn't it? Queen has four card, and J has four card. Altogether, out of 52 card, we have 12 face card. Am I correct or I'm wrong? Am I correct or I'm wrong? Guys, are you getting my point? Okay. I will give you one example where the Bayesian theorem is implemented in your case studies. Let's have a look at it. Just I will give you one use case. Listen to me very carefully. I will keep a play card deck in front of you. Keep a play deck in front of you. Okay? Play card deck. Okay. Now the first thing is I want you to pick one card from the deck, and the condition apply as the first card is king card out of the face card. I mean to say that let's assume I keep a play card deck in front of the desk, and if you pick the first time any card, if you find as number three, you can ignore. Are you understand, guys? You wanted to pick a play face card. What are the face card? Out of 12, that's no, not out of the 12 face card. See, let me tell you, you have a 52 card in front of you, guys. Isn't it what I'm saying? Just 1 second, guys. Right, వినాయక బొమ్మ బ్యాక్ సైడ్ లో కిరణ్ స్కూల్ దగ్గర. మీరు అంటే okay, guys. So very simple. What I'm trying to say, I'll repeat again. Very simple. In the play card, we have 52 card, guys, isn't it? I keep in front of you. So when you pick the first time, you all the time, whenever you pick, that should be a face card. And what is the probability of king's card out of the face card, out of the 12 face card and out of the 52? So that's, have a look at it. I wanted to four. You said four, but let's do this to find the probability of king out of the face card, isn't it? Here, probability of A by B, let's apply the Bayesian theorem. A by B is equals to probability of B by A into probability of A divided by probability of B. Did you understand, guys? Now, when you understand this, so face cut, king's face is always 1 into what is the probability of king? 452. Can this or not? Divided by face card. What is the probability of face? 12 by 52. When we solve this, find 1 by, that means out of the play card, when you pick it three times, out of the three face card, whenever you pick, at least you get one time as a king's card, guys. This is what solutions. I hope you understand, guys. So the reason is every lot of places the Bayesian theorem equation is implemented. Are you guys clear? So very simple. There are two type of things we understand. One is posterior probability, one is prior probability, one likelihood, one is marginal likelihood. Did you understand or not? So the two part we clear. So the first thing is conditional probability, we clear now, and Bayes theorem or Bayesian theorem we clear, isn't it? If you not understand conditional probability, you never understand Bayesian theorem. Now let's go to Naive Bayes. Let's go to Naive Bayes algorithm. Okay, so I'll give you small data set, and once you understand the small data set, you go back to, we go back to this one, guys, and this is what Bayesian theorem formula. That's what I'm saying. Every algorithm is a math equation, and I'm telling you the math equation. Same things you can find out as parameter tuning, hyperparameter tuning in each and every model. Okay, where do you use in real time, sir? Calm down. I will tell you. I already, did you attend the session or not attend the session? Don't know. What's your name? Clearly, I mentioned here in real world ticket price missions. Did I mention? By the time I think you didn't join. Are you guys understand or not, guys? Oh. Now have a look at this. Okay, so Bayesian theorem is clear. Now I'll talk about Naive Bayes now, and I will give you the scenario where exactly it's been. Naive Bayes algorithm. Once after my explanation, you go and check any book, you go and check any material, you go and anywhere you can find, you see the, you understand the knowledge, guys. Am I clear? Also, I will explain most of the use cases if time allows today, or that's what I said. I will take 2 days to complete this because this is a little, I mean, technical. So I want you to take time to explain all the concepts, guys. Remember, I have one data, isn't it? And this data set contains, look at this. This has fruits data set, okay? And everybody know Bayesian theorem equations now. Yellow fruits, sweet fruits, and the fruits are long and total. Understand, overall, we have 650. Fruits are orange, I mean, yellow orange are 350, sweet orange are 450. Definitely orange never be long. Let me tell you, total we have 650 orange fruits we have, guys. Okay, 650 orange we have. Out of 650, 350 orange is yellow. Out of 650, 450 orange are sweet. And of course, orange can never belong. That's why we mention as zero. What I'm trying to say here, guys, I want you to know, do not add this 350 plus 450 is 800. Do you understand what I'm saying? I don't want you to add this. Let's assume you have total 650 orange in your bag, and out of 650, 350 orange is yellow and 50 orange is sweet. Clear this part, guys? Clear this part? Now the next one, banana. Out of 400 banana, yellow bananas are 400. Out of 400, 300 banana are sweet, and out of 400, 350 are long. Understand, guys? And other one is mixed fruit. Others means it is a mixed fruit. It could be combination of anything. So we have total 150 fruit, and out of 150, 50 fruits are yellow, and 100 fruits are sweet, and 50 fruits are long. I'm saying I don't want you to add this because no need to add, but yes, you can add on this way. 350, guys, are you getting any disturbance from my background? Did you get any disturbance from my background? No, right? Is it disturbs? No, sir. Get impacting you? I mean, it's very annoying. No, thanks. Okay, because some work is going on, so I cannot stop them to do that. Well, one moment. Let me close my door. It's better. So if you find that, have a look at it. Just 1 second. So now have a look at this. 350 plus 450 is 800. 450 plus 400 is 850. Now 400, isn't it? Now you can add this. Now I have one data sets right now. Don't we cannot add them. I'm not understand total columns. Very simple, buddy. This is what. Assume you have three bag. In the three bag, you have 400. Third bag, you have 150, right? And out of 650, you randomly pick fruits from the shop. Out of six, you have 350, 450 are sweet. Out of 650, 350 is yellow. Out of 650, 450 is sweet. I mean to say that, out of 450, make it, I want you to think what I'm trying to say. Understand, guys? I want you to think what I'm trying to say. So 350 plus 450 is 800, 450 plus 100 is 850. And what you wanted to predict, out of this, you wanted to find out of all these fruits, you wanted to find out which is the fruit is yellow, sweet, long. Are you getting my point? How do you find out of the which is fruit which satisfy all the conditions? Fruit is yellow, fruit is sweet, and fruit is long. Do you understand, guys? So how to find out? Let's do it today. Using help of Bayesian theorem, we can classify the data. So how to classify the data? Have a look at this. The first thing, I need to compute yellow with respect to orange. Understand, guys? I wanted to compute yellow with respect to orange. When you say yellow with respect to orange, what I can do, so how to compute this one, guys? This is the equation or not? A by B, yellow with respect to orange. Can we implement this formula to it here? Or probability by probability of orange? Guys, are you getting my point? What I'm trying to say? See, if you understand the small example, you go anywhere in the world, you snake by them. Trust me. Whatever the example, it looks like very easy, very easy. You can find out. This is same things they've been implemented, and that's what we are doing in every hyperparameter tuning. Trust me, guys. So here I try to find yellow with respect to orange and probability of orange by yellow. What is the equation? 350. What is the total fruit? 800. So 350 by 800 into probability of yellow is 800 out of 1200. So you may ask a question, sir, how do we get this? Very simple. A coin has head and tail. What is the probability of head? Can I say 1 by 2 or not? What is the probability of tail? What is 1 by 2? So the same way, if you understand, you can find out all those things. That's what I'm sharing this PPT. This PPT now very powerful, guys. I completed all the course materials from the data science. Do you know this, guys? I've been done Coursera. I've been done Upgrade, Great Learnings, and some of the online tutors, Edureka, and some of them Simple Learn, some of them. Plenty of things I covered a lot of things as well. I covered all these things. I summarized and I can teach into you. So don't need to worry. Be happy and learn and apply interview. Am I clear or not? Are you getting my point? What I'm trying to say? Everybody, 8:30 a.m. batch. So here, yellow with respect to orange equal to yellow in of yellow. Find out how many oranges we have. 350 oranges. What are the yellow oranges? We have 800. So that's why 350 into 800. Clear? What is probability of yellow? Total yellow is 800 divided by total fruit 1200 divided by probability of orange 50 divided by 1200. When you compute this, you got output as 0.53, 0.3. Here or not, guys? Yellow with respect to orange is got 0.53. Can we compute sweet with respect to with how to compute? Just change in terms of yellow, just apply sweet and apply sweet. When you solve this, you get output as 0.69. Along with respect to orange, into anything is called zero. So fruit with respect to orange, I got my output is zero. I got output as zero. Now the next one is, this part is clear. Now let's compute this one now with respect banana. To compute fruit with respect to banana, I need to compute yellow with banana, sweet with banana, and long with banana, isn't it? Just give me one moment, guys. Okay. So once we compute fruit with respect to banana, we need to compute yellow banana, sweet banana, and long banana. So how do you do this? Apply the same methods now. Yellow banana, I got output as 1. Sweet banana, I got output as 0.75. Long with respect to banana, we got 0.87. What is the probability to be 5? Now, fruit with respect to others fruit, mixed fruit. Then what you do? Yellow with others means with you can implement the same formula. When you compute, you got the value of 0.33. Sweet with respect to others, you got value of 0.6. With respect to others, you got 0.33. So when you do this, so we have all those things, guys, right? Can you please tell me which one has highest probability? Which fruit has highest probability? Anybody? Which fruit has highest pro? We have three probabilities, guys. Fruit with respect to orange is 0. Fruit with respect to banana is 0.65. Fruit with respect to is 0.072. Banana. Now, can you check banana is the fruit which satisfy is yellow, sweet, and long as well? Did you understand, guys? So this is called Naive Bayes algorithms. Team, everybody's understanding the mathematics part of Naive Bayes algorithms. We have three type of Naive Bayes. So very simple. I repeat once again, and tomorrow we close Naive Bayes algorithms and how exactly we've been implementing time. I will tell you with the help of Bayesian theorem. Let me repeat once again and quick conditional probability. There are two conditions given, A and E these two events are independent, means not dependent with each other. Okay, this is called independent formula. A intersection B divided by probability of B. So if this has need to find the probability of A. I mean to say, if you apply this, the formula, I mean, B equal to 30 by 100, A intersect B 20 by 100, and A by B is 0.67. We got this now. Now is Bayesian theorem. And this Bayesian theorem, the formula, as I told you, if we solve the two formulas, okay, have a look at this. Just now, let's talk about this is divided by 1 divided 1. If I multiply both, we can find out A intersect B into 1, B intersect A into 1, both the same. So that's why I mentioned A intersect B. A by B into probability of B equals to B by A into probability of A. So if I take A to, I take this B as a denominator of other part. I hope you know the LHS, RHS calculations, all those things, guys. So this, I hope understand how to create the equations. So this part is posterior probability. This part is likelihood. This part is prior probability. This part is marginal. And we talk about one generic example to understand this one. The next one is bias algorithms. In the small data set is given, in the data sets, you need to find out which is the fruit, check with all the conditions. So that's why I need to compare fruits with orange versus fruit with banana versus fruit with others or mixed fruit. So how to compare fruit with orange? To compare fruit with orange, we have yellow orange, yellow with respect to orange, I need to apply Bayesian theorem, and sweet with respect to orange, I need to apply Bayesian theorem, and yet long with respect to orange, I need to apply Bayesian theorem, and I will multiply yellow into sweet into long, and I go output as 0. The same way, fruit with respect to banana, I need to compute with respect to banana, yellow banana, sweet banana, and long banana. So yellow banana, we have 1 into 0.75 into 0.87 equal to 0.65. Fruit with respect to others is called, I mean, 0.33. Yellow with others is 33, and sweet 66, 33. Output is 0.72, means 65 percentages. 65 means what, guys? 65 percentages. 0.07 means 7 percentages. Did you understand? And finally, you can say 65% is the, I mean, fruit with maximum ability satisfy all the conditions, guys. Are we clear or not? Everybody's clear? Yes, guys. Today we understand pro share you the variance of naive Bayes. What is multinomial naive Bayes, Bernoulli naive Bayes, Gaussian naive Bayes? This is three parameters, and then I will implement on real time Bayesian would help for ticket confirmation tomorrow. I will talk about it, and then we complete naive Bayes algorithms tomorrow. Did you guys are clear or not? Everybody's understand? Okay, and I'll stop here and you guys and have a good day.